ready when you are.
Imagine, after sitting at your computer for hours on end, you're laying in bed struggling to fall asleep while being totally exhausted. Then, once you do fall asleep, you wake up several times throughout the night, barely getting enough rest. According to a study in the US, this is the reality for 14.5% of Americans. They're experiencing something called sleep insomnia due to an overexposure of blue light in their digital devices. Many eyeglass companies and businesses have been developing a new solution to this worldwide problem. Blue light glasses, a device that claims to filter out this damaging light. Being a recent invention to the 21st century, they've sprung in popularity since the pandemic, with social distancing causing an uprise in the use of digital technologies in our everyday lives. Hi, my name is Remi and I attend Fraser High School.
And I'm Sara and I attend Cousinville High School, and this is our presentation on the effect of blue blocking protection lenses on the intensity of blue light. Before we begin our presentation, here's a table of contents that we will be following. We will begin with background information and the purpose of our experiment, then our problem statement and hypothesis, third, our experimental design, fourth, our data and statistics, and lastly, our conclusion.
Now let's move on to some background information and the purpose of our experiment. So what is blue light? Blue light is located on the visible light spectrum with a wavelength between 450 to 495 nanometers. About 1/3 of all visible light is considered blue light. The intensity of blue light depends upon the light source that it is being measured from. Sunlight is considered the greatest source of blue light. Like sunlight, there are other ways you can find blue light, such as mobile devices, computer screens, TV screens, and fluorescent and LED light bulbs. So what is so damaging about blue light? Well, our eyes actually can't sufficiently block blue light, so it can enter through the cornea and lens of the front of our eye and reach the retina. The retina is the part of our eye that processes light into images for us to see. Long-term exposure to blue light can lead to damage to the retinal cells in our eyes and can lead to other vision problems such as age-related macular degeneration, cataracts, or even eye cancer.
To continue with damaging effects of blue light overexposure can cause sleep insomnia. There are two types of sleep insomnia that can be caused by this. The first type is sleep onset insomnia. This is a condition where you struggle to fall asleep at night no matter how exhausted you may be from a long day. Secondly is mid-sleep insomnia. This is a condition where you do fall asleep as normal, although you wake up multiple times throughout the night, and when you do wake up throughout the night, those might be the instances where you struggle to fall asleep. Both of these affect the quality of your sleep as well as the amount of sleep that you are getting at night, which can affect your circadian rhythm or your body's 24-hour clock. This is because your body does not produce melatonin as it regularly does, not allowing yourself to feel aroused to the idea of rest.
So what are blue light glasses and how can they help? Blue light glasses have a built-in micro layers in their lenses that actually alter the way that light can be transmitted or reflected, and in turn can reflect or absorb blue light. They're most commonly found in prescription or non-prescription glasses. As you can see in the diagram here, this would be typically how blue light would be reflected off blue light glasses. Now, glasses that typically reflect blue light have the special coating in them to make them appear to have more of a bluish tint. Whereas in the diagram here, you can see that blue light is being absorbed. In this case, blue light glasses typically have more of a yellowish tint. Blue light glasses can prevent eye strain and other eye-related injuries, and can also allow for humans to regulate a more normal circadian rhythm. So in our experiment, we focused on the intensity of blue light wavelengths with the use of blue light glasses and without, in order to test their ability to protect our eyes from long-term exposure to blue light.
Now, our research can produce two different types of conclusions. The first conclusion being that the blue light protection lenses do work and do reflect a portion of the intensity of blue light. If they do reflect a portion of the intensity of blue light, this can help prevent sleep deprivation as well as sleep insomnia, which is previously mentioned. This can also lead to more efficiency in night shift workers. If the opposite conclusion is produced, being that the blue light lenses do not work and do not reflect a portion of the intensity of blue light, this can expose many eyeglass companies who are promoting a product which does not work. This can also open the door for new solutions to this worldwide problem to be found. Now, before we get into our experimental design, here are 3 standard values that are crucial to this experiment. These are the values that our collected data was compared to. The first standard value being for incandescent light, which is the intensity of the blue light, being 14.575 watts per meter squared. For our second light source, which is LED light, the standard value is 43.823 watts per meter squared. And lastly, for our third light source, which is a laptop light, our standard value is 6.689 watts per meter squared. Now, into our experimental design.
So for our problem statement, we wanted to determine whether if blue light blocking protection lenses in glasses can reflect the intensity of blue light from 3 different light sources to avoid reaching the human retina.
And after that, we hypothesized that the blue light protection lenses will reflect a portion of the intensity of blue light from incandescent light, LED light, and other device light, which in this case was a laptop. Now our experimental design. This is how our procedure was set up for the first 2 light source, incandescent and LED light bulbs. This is different from the third light source, being that the light bulbs could not stand on its own. The materials used included a cardboard box, a pair of blue light protection lenses, which remained consistent throughout the entire experiment, a fiber cable, which was able to calculate the intensity of the blue light, which was not reflected from the lenses, a spectrometer, which was crucial to this entire process, a lamp which held up the light bulb inside, and this light bulb was determined based on the randomized order in our Google spreadsheet. The lamp was plugged into the wall outlet to be able to turn on the light bulb. Then a USB cord, and lastly an adapter, which connected the USB to our MacBook computer, which had the downloaded SpectraSuite software, which allowed us to analyze our data and able to retrieve graphs and our statistics. Next is the setup for the third light source. This light source is laptop light and was different from the other one, being that it could stand on its own. So the materials in this one remain consistent, although the main difference is the laptop light using the same cardboard box, which allowed for the researcher to hold the glasses and the fiber cable consistently. The same pair of glasses, which again is crucial for this experiment, and our fiber cable, which was connected to our spectrometer, which was also connected to the same computer. Now is a video of our procedure. In this procedure, researcher 1 is hitting the record button on the laptop and allowing the trial to run for 5 seconds. This is because when the record button was hit, the graph spiked, and then the 5 seconds allowed it to sit and settle. Then after the 5 seconds was over, the researcher hit stop, and then we analyzed that graph. Researcher 2 held the cardboard box, held the glasses and the fiber cable over the cardboard box, allowing for the fiber cable to remain in the middle of the glasses to get the best results.
Now let's move on to the data and statistic portion of our research. So here is a sample trials of our light sources. Over here you can see, and this is using the SpectraSuite software, we focused on the intensity of the light measured in watts per meter squared. Over here you have the wavelength for each trial. This is the average wavelength between the highest and lowest range that was selected within the program. As you can see, all of these wavelengths are between the range of blue light between 450 and 495 nanometers. And within just these couple of trials, you can see that the LED is significantly higher than the incandescent in laptop. We hypothesize that this might be because the LED is a brighter light bulb, so typically, this isn't just the blue light glasses not working as well. I think it's just, we believe that it was because it simply was just a brighter light bulb. And then over here is kind of a graphical version of what I just explained. Again, you can see all 3 ranges are within that 450 to 495 nanometers, and here you can really visually see just not only for blue light, but for the entire rainbow, the intensity is just significantly higher, which shows that it's not just the glasses, it's more of just the LED light bulb being brighter. So before any statistical tests could be run, we ran a comparable box plot with all 3 of our data sources, our light sources. As you can see, the standard values for each light source can be shown by the line going down the graph. And then also, all 3 of our light sources were fairly normally distributed, with the exception of the LED light bulb being slightly right skewed, but other than that, it was fairly normally distributed. Also as well, the incandescent light bulb and the LED light bulb did seem to have a couple outliers. However, between all 3 data sets, there was no overlap whatsoever.
Now before a statistical test, which in this case was a 1-sample t-test for means, was able to be run, there were conditions that had to have been met. As mentioned previously, this experiment was randomized, being that the order of trials was randomized in our Google spreadsheet before collecting data. Now, the normality condition. This is a condition where the data is normally distributed either on a histogram or any type of box plot, which, as seen previously, this was met. Now, the large counts condition. This condition states that the number of trials had to have been at least 30 for this to have been met. And each light source did have 30 trials run, being for a total of 90, which leads to this conclusion being met. Now, the 10% condition. This condition is different, being that this can be discarded. This is because we ran an experiment, which means that the 10% condition does not apply.
Now for our null hypothesis, which states that the average intensity of blue light using the blue light glasses is equal to the standard value of intensity without the use of blue light glasses. This means that there is no difference between the amount of blue light that is reaching our eyes using glasses versus not, basically stating that the glasses have no effect. Whereas our alternative hypothesis states that the average intensity of blue light using the glasses is not equal to the standard value of intensity without using the glasses. This means that there is in fact a difference between using the glasses and not using the glasses, and that basically the glasses are doing as they intended to do and are reducing the amount of blue light that is reaching our eyes. Now let's move on to a sample calculation of the t-value, which is then used to calculate the p-value in our statistical analysis. So first we're going to have the sample mean, which in this case would be the average intensity of blue light using the glasses for the specific source that we would be using in the calculation. Then we have the population mean. This would be the standard value of intensity of blue light without using the glasses for the specific light source. And then this would be over the standard deviation divided by the square root of the sample size. So after all this is plugged in, we would get the value of negative 11.488. This would be done 3 separate times for the 3 separate one sample t-tests we'd be doing for each light source. So after 3 of our tests, or one sample t-tests are conducted, we have a summary of our results here. And as you can see, the incandescent and the laptop p-values are significantly lower than our alpha level of 0.05, at almost being nearly 0. And as you can see in the graphs here as well, this would mean that our hypothesis would be rejected. And this, as I stated earlier, would mean that there was a difference in the amount of blue light reaching the human retina between using glasses and not. Whereas in the LED, it was only slightly greater than the alpha level of 0.05, being 0.082. This would lead to failing to reject the null hypothesis, stating that there is no difference in the amount of blue light reaching the human retina between using the glasses and not.
Now, our conclusion.
Now, although the statistical analysis for the LED light bulb does differ from the incandescent and laptop screen, there can be assumptions to be made for our final results. Due to limited time and resources, unfortunately, our standard values were only based on one trial. Given that this is not statistically sufficient, there could be bias in our statistical analysis. As I just previously stated, the incandescent and laptop values were significantly less than the alpha level of 0.05, leading to rejecting the null hypothesis. Whereas the LED was only slightly greater, with a difference of about 0.032 from the alpha level. Now, considering the fact that the LED light bulb is significantly brighter than the incandescent and laptop screens, that could possibly skew the data and make it seem like the glasses don't work as well. And considering the accuracy of our standard values, we can actually assume across the board that our null hypothesis was actually rejected, therefore making this statement false.
Now for final takeaways.
Now, in order to understand the science behind the results, we need to get a basic understanding of how light can be absorbed and reflected. Light can be reflected when there is a difference in the index of refraction between two materials. And in context of our research, this would be the lenses of the glasses. Now, light is absorbed when the frequency of light has the same energy levels of the electrons in the matter. And in context of our situation, that would be the filter lenses. Now, considering the fact, looking back at the information that was discussed at the beginning of this presentation, this agrees with the final conclusion we will be making for our research.
Now, here are 4 main points that we took away. First, being that the blue light glasses do reflect a portion of the intensity of blue light, being that they do work, which leads me into our second point, being that they should be used in glasses. This can be in prescription or non-prescription glasses, highly recommended when you are going to be staring at a screen for long periods of time. Now, because of using these glasses, this prevents eye damage and protects your eyes from eye cancers or eye damage that could cause surgeries. Lastly, this can prevent sleep insomnia, which also will prevent sleep deprivation, allowing for yourself to be the most concentrated when you need to be, as well as keeping your immune system regular.
Now, with more time and resources, more research could be done. We could use more light sources, such as fluorescent light, maybe even use sunlight or even light beams to further understand if this could change the quality of the glasses. We could also use different types of glasses. We could do a 2-sample t-test with and without blue light glasses that have a prescription to see if the actual prescription itself changes the efficiency of the blue light lenses. And then finally, we could also maybe just use the light sources we have been using and just change the amount of power or watts in the light bulbs to see if that has a significant effect.
Now, here are some flaws to our research. First, being that we had a lack of time. Although MMSTC did devote 1 full week for trials and 1 full week for pre-trials, we were unable to use those weeks to run our experiment because we did not have the spectrometer on hand. We went to Wayne State University to be able to use their spectrometer, which caused us to have to learn how to use that new material the same day of trials. We had 3 hours to be able to learn how to use the material and conduct trials and collect standard values to be able to use in a statistical analysis, which could have left us with flaws or bias in our data. Now we'd like to acknowledge Professor Robert Haar at Wayne State University, who is specialized in optics and physics, which allowed us to use their spectrometer to be able to run our experiment, as well as providing us with a location to run trials. He was also our professional contact and provided us with fast responses in our lack of time. Next, we'd like to acknowledge Mr. McMillan, our AP Physics teacher, for providing us with help with our scientific processes, as well as materials and support throughout this process. Next is Mrs. Gravel, our IBS teacher, for helping us with the format of this presentation, our final paper, and for support with going to Wayne State to run our trials. Lastly is Mr. Moore, who helped us with our statistical analysis portion of this experiment.
Here's our works cited. Thank you for listening.
Do you have any questions?
All right.